Okay, so we are getting ready to basically interpret some graphs, okay? And it's asking us for several different things. It's asking us to state the domain and the range, which we've been doing. And then it's also talking about stating the intervals where the function is increasing, decreasing, and constant. Okay, so we're going to talk about that. And then also you're finding the value of your function when x equals a certain number. Okay, so we'll do that. Mine, I had to do mine on a second page because I didn't have enough space. But so what I want you to do first is what we have practice with is writing your domain and your range. Okay, so look at your first graph. See if you can figure out what your domain and your range is. We're writing these in interval notation. And then we'll talk about the increasing, decreasing, and constant and what that means. Do you have one of these on your desk? Yes?
Range, how do you tell?
Go from the bottom to the top.
But if there's a point, does that mess anything up, or is it still like in the middle? There's a point that's in between the negative.
So in this one, no, because all of my points are closed. We are going to get to one, like down number 5, where you have some open points. So that will change.
So the closed one doesn't matter though; it'll still be negative.
Right. Okay, so remember we did this the other day with our domain and the range. The domain, we're looking from left to right. What values on the x-axis does my graph cover? Do you notice we have arrows on either end of our graph? So that means it's going to go forever to the left and forever to the right, which means my domain is going to be, negative infinity to positive infinity are all real numbers, right? Okay. What about the range? We go from bottom to top, but again, I have arrows on either end of my graph. The left side, that graph is going up forever and ever, right?
Yeah.
The right side, that graph is going down forever and ever. So what would my range be? Yeah. It's all real numbers as well because those arrows tell me it continues up and down forever. So far, so good. Now, the increasing, decreasing, and constant, that is something we haven't talked about yet. And it's a matter of reading our graph. And we always read from left to right. So what I'm going to do first is I'm going to abbreviate increasing, decreasing, and constant. We're going to just go through this graph piece by piece, decide whether each section is increasing, decreasing, or constant. Increasing means it's getting bigger from left to right. Decreasing means it's getting smaller from left to right, and constant means it's staying consistent, okay? Also, when we're talking about the intervals in which it increases, decreases, or is constant, we're reading from left to right. So which values are those? Yeah, negative to positive, but what letter? X, okay. So when we talk about these, we're always talking about the X values, not the Y values. And also, when we do these intervals of increasing, decreasing, and constant, we use parentheses always because we can't be equal and decreasing at the same time or equal and increasing at the same time. Okay, so for increasing, decreasing, and constant, you're always using parentheses on either side. Is everybody ready? So I'm going to start on the left side of my graph. I'm going to kind of highlight it so you can see what I'm looking at, but you can follow along on your graph. If I start at the very edge of my graph and I go until it changes positions to that point right there, is that going up or down from left to right? Down. So that would be a decreasing interval. And what I need to figure out is how I write it. If it is forever going that way, it's going to be going decreasing from what number? Negative infinity. And then it decreases until I hit this X value. What is the X value right here? Negative 2. And then I'm going to put a parenthesis there. I'm going to just go from left to right. So I may have to come back and add another interval for decreasing, but we'll just have to see what our graph gives us. Sometimes we don't have increasing or decreasing or constant. Sometimes we only have a couple of each. All right, my next section goes from here to here until it stops moving. Is that going up or down? Up. Okay, so that would be increasing. And from what X value to what X value? Negative 2 to negative 1, okay? So far, so good? Then that next section of my graph until it changes movement again is just straight. What would that one be? Constant, and that's from what x value to what x value? -1 to 0. Everybody kind of okay so far? The next section is going to be going which way? Down. So that is going to be another decreasing interval. So we're going to put our union here because we have two sections that are decreasing at least. I can write my letter here. And it's decreasing from what x value to what x value? 0 to 2. What about the next section? What is that doing? Increasing. So we're going to have another increasing interval. So we're going to go u, and it's increasing from what x value to what x value? 2 to 6, yep. And then this last part is going to be doing what? Decreasing. And what's that interval going to be? 6 to infinity. Okay. So in this particular graph, I had two sections that were increasing, so I wrote those with my union in between. I had three parts that were decreasing, and I only had one part that was constant. Okay. Not every graph is going to give you all three sections. You have to just look at your graph, read it, and see what happens. Is everybody okay with that? All right. Now, it asks us, I think I wrote the wrong thing. What does it say on yours? It says to find f of what three numbers?
0.
Okay, so I'm going to change this 6 to a 0 because I think I typed the wrong thing. We've done this part before. We've looked at a graph and we found the value of the function when x equals that number. So what I would like for you to do is look for the ordered pair where x is -2. And that will be the answer to the f of -2 question. So we're finding f of -2, f of +2, and f of 0. We're going to find those three. This is still the same graph. I just had to change slides because I didn't have enough space. Okay, again, the number in your parenthesis is your x value. So I'm looking where x is -2. Which one of these ordered pairs? I have an x of -2, so what would the y value be? -2. The next one, I'm looking for the ordered pair that has an x value of 2, which is here. What is its y value? -2. And then what about my 0? What is y when x is 0? 1. So we are basically going to be doing this for each graph. We're going to be doing all parts. Domain, range, increasing, decreasing, constant, and then find the value of f at -2, f at 2, and f at 0. So I would like to give you just a few minutes and try to do number 2 by yourself. Do the domain and the range, try your increasing, decreasing, and constant, and the value that All right, let's take a look at number 2. Again, we're doing the domain, the range, increasing, decreasing, constant, and finding the values of f of -2, 2, and 0. So let's start with the domain. Does it go forever left to right? No. What's the first piece it reaches on the left? Okay. Yes. I was like, no. -4, because this last ordered pair right here is not actually listed, so you have to figure out what that is, which is -4. The bracket? Because it's equal to 4. That's a closed circle, so we can equal 4. If that were an open circle, which we'll get to in number 5, you would just put the parenthesis. Okay? Domain and range, we can have brackets, just not for increasing, decreasing, and constant. And then it goes from 4 all the way where? To infinity. What about my range? Because you're going from left to right. Right is positive infinity. So, do you see how this doesn't have an arrow pointing that direction? So I don't go all the way, I don't go past this point right here for my domain. So the first part I reach is this -4. And then this arrow tells me it's going to go forever that way. So that's going to be from -4 to positive infinity. Does that make a little bit of sense? Range goes this way. Does this go forever down? So we're going to start at what? What's forever down this way? -infinity. And I go until what's the highest point on my graph? 3. Okay, so my range is going to be from -infinity to +3. Can I equal +3? Yes. Okay. Okay, so that domain was just a little bit different because I didn't have arrows on either end of my graph. I had a point on one, so that means it stops. Is everybody ready? Okay. Okay, I'm starting on the left side. What is my first interval going to be? Which one? Increasing, decreasing, or constant? Constant, and it's going to be from -4 to -3. Okay. All right. What about the next interval? Is that increasing, decreasing, or constant? Decreasing from -3 to X values for increasing, decreasing. So that's -3, and it stops at.
Oh, do you not do it at the other point? Even if it's, okay.
When you're doing your increasing and decreasing, you're looking at the X values only. Because increasing and decreasing goes from left to right with your X values. So what's the X value right here when it starts to decrease? -3, and it stops decreasing at 0. Okay. And then what about the next section of my graph? What is that? Constant. So that's constant from 0 to 1.
So you don't have to do every individual little section if it just keeps decreasing.
Right.
Okay.
Like if it just continues with the arrow and it's continuing, then you just keep going all the way. Yeah. All right. The next section that has until it changes movement is right here. Which is that one going to be? Increasing, decreasing, or constant? Increasing. So from 1 to 2, you said? Okay. And then the last one is constantly what? Decreasing. So it starts decreasing at 2 and it goes forever, which takes me to infinity. Kind of okay. We're going to find our values. Yeah. What's f of 0 going to be here? -1. What about f of -2? And then f of +2? 1.
Is there going to be a point where we have to find the intervals instead of looking at the graph? Or
What the
the F0, F-2?
Well, you're going to look at the graph, but it's not going to be as obvious because it's not going to be an actual ordered pair listed, which is what we're getting ready to do on number 3. Okay. So for number 3, what I would like for you to do is start with your domain and range, then do your increasing, decreasing, and constant. Hold off on finding the values of your function because we need to talk about this one. This one is a little tricky because my intervals are different. And also all of my ordered pairs are not listed. So what I want you to do for number 3, domain, range, increasing, decreasing, constant, and pause there. Okay. Domain, range, increasing, decreasing, and constant for number 3, and then just hold tight. For my domain, I have arrows on either end of my graph, which means it's going to go forever in both directions. So my domain is going to be. Okay. Is the range going to be the same in this case? Yes, because again, I have arrows on either end. It's going to go forever down and forever up, which is from -infinity to +infinity. So what I want to do first is start at the left side of my graph until it changes movement. I thought you were sick. Okay, so starting at the bottom, we're going to go until this point. Are we increasing or decreasing there? Increasing. So we're going to increase from negative infinity to negative 3. Okay. And then we change our direction and we start doing what? Decreasing. So my decreasing interval is going to be from, where did I start decreasing? Yeah. Negative 3 to positive 3.
If there's a point there, you ignore it.
Yeah, because it continues to decrease. It doesn't change direction at that point.
Okay.
It still goes down, right? So the only time we stop is when it changes direction. It just starts kind of sliding down the slide. You're still going to think about that as a slide. You're still going to keep going past that, right? Until it starts moving a different direction. Does that make sense?
Yeah. Sorry, I just keep getting confused when I say points.
Okay. And then what about that last one? What is it going to do? And which, increasing, decreasing, or constant? Increasing. So I'm going to put a interval, union, can't talk, sorry. Are there any constant pieces in this graph? No, so I'm just going to either leave it blank or you can write none if you want to. All right, now here's the part I told you to hold off on. And here's why. What we need to do is we have to pay close attention, because when I did this first period, I wasn't really paying close attention because I hadn't looked at it since I wrote the notes. But do you notice how this says negative 10? Is that really 10 away? No. So that means each line is actually what? 2. Okay, so we have to be careful when we look for these, because I don't have an ordered pair that has an x that's negative 2 or positive 2. So I'm going to have to actually figure out where those are on my graph. Okay, so we have to pay attention to what the graph is labeled as. What about my y though? Are those single units? Yeah, okay. So if I want to know what f of negative 2 is, I've got to first of all figure out where negative 2 is. And because this is my, my interval is messed up, here's negative 2. And what I want to do is go to my graph and see what my approximate y value is here. Okay. So think about it. If we started here at negative 2, we have to go up 1, 2, 3, and that looks to be about how far? Halfway. So my y value would be 3 1/2. Even though there's an ordered pair not listed there, we can still figure out what it is by finding where my graph crosses x at that point, if that makes a little bit of sense.
Yeah.
Kind of, sort of. Let me erase my... So it crosses right about here, so I just had to figure out what y value that was. And it's an approximate, so we don't know exactly. That's why I just said it looks to be about in the middle, so I'm going to go 3 1/2. What about f of 0? Was that one easy to find?
Yes.
Yeah. I got an ordered pair, right? Huh?
I thought we were doing F of 6.
Does it say that on your paper too?
Well, it says F of 0 on the paper. You said switch it to 6.
Oh no, I switched my 6 to 0. Up here. Sorry. I might have said it, but I probably said it backwards. But I switched it to 0 up there. See, where I had a 6, I switched it to 0. But I could have definitely said it backwards. That doesn't. It wouldn't surprise me. All right, and then let's find f of 2. So again, our x is on 2. Every one line is 2. And so I'm going to go down to my graph, 1, 2, 3, and that one looks to be about a negative, what? 3 1/2. Okay, so sometimes the ordered pair is not listed, so you have to figure it out. I'm not going to do that. I'm going to try to make it as easy as I can for you on the quiz, okay? So if it's not listed, it will be a very clear point that you can see. Bless you. Is everybody kind of okay? All right. I want you to try number 4 all the way through. We're going to need to do 5 together because we've got a couple of different things to talk about there. But I want you to try 4 all the way through. Do every... All right. Number 4, starting with my domain. I've got arrows on either side of my graph pointing to the right and to the left. So that means this thing is going to be from... Yeah. Now, the range is a little different this time because do I have any of my graph down here in the negative values? No, it doesn't start until what y value? 0. And then that's going up forever, and that's going up forever, so it's going to be from 0 to infinity. Is it equal to 0? Yes.
So does it have to have like a close on it?
Well, the line, it means it's closed, essentially. It would be a very clear open spot if you were not meant to equal it. All right, then we're going to go increasing, decreasing, and constant. Starting from left to right, what is this first section doing? Left to right. What am I doing? Decreasing, and what would that interval look like? Negative infinity to -3, okay. And then this middle section would be what? Constant between what numbers? Okay. And then this last section would be increasing, and what's that interval? 3 to infinity. What is the y value when x is 0? Okay. What is the y value when x is -2? And what is the y value when x is 2? Okay. Even though those ordered pairs are not listed, this graph is graphed not trying to trick me. All of my lines are 1 unit, so at -2 it's 0, at 0 it's 0, and at 2 it's also 0. Okay? All right, let's take a look at 5 and talk about why 5 might be slightly different. What do you notice in 5 that we haven't had in any other graph? We've got open circles, which means we are not equal to. Think about your number line when we graph. When we use open circles, that means it's not equal to that point, right?
So how are you supposed to find the domain and constant?
Let's talk about that. Domain, which way do we go? Left to right. Okay, so let's start. For the domain on the left side, this is going forever that way, correct? Which means we're going to start where? Negative infinity. Okay. And then I'm going. I'm going. But do you notice how on the red one I have a hole right there? So normally a hole says I need to skip that value because it's not equal to that there. However, look at the blue and the hole on the same x value. That one is what? Closed. So doesn't this closed one basically cover up that one?
Yeah.
Because that says it's not equal to 0, but this says it is equal to 0. This is what we call a piecewise function. We'll get to those later. But so it's going to go from negative infinity. Even though there's a hole there, that closed part covers that. So I can continue on to the next hole, which is at what value? 2. And you notice how I have a hole both of those? So that means I cannot equal 2 anywhere. So my domain is going to start, like we said, from negative infinity, and it's going to go all the way up to 2. Because both of these are open, we cannot actually equal 2. That's why I put a parenthesis there, right? But we skip that 2, and then doesn't it continue forever to the right? So then we're going to pick up our second interval, which is going to be from what? 2 to infinity. Okay, kind of like on the number lines we were doing. We're not used to looking at graphs, but on the number lines, okay, if we had this and it was everything this way and everything that way, it's the same thing, right? Makes sense a little bit, sort of, maybe. All right, range is also a little trickier. We start from bottom to top with the range. What is the first part of my graph where my range touches? -1. Okay, now here's, and I'm not going to be too particular about how you write this, but because of that open circle and because this is not everywhere, I only have part of my graph that has a range with that -1. So we wouldn't want to put brackets. We would want to put the braces here. Okay. Again, I'm not going to be too strict on that. If you just put -1 without a symbol, I would be okay with that, all right? But because of that open circle, we can't do the brackets around it because it's not equal to -1 everywhere. And then I have a space, and I don't pick back up until what? 0. And then this one goes up. But let me ask you this. That's open, but does the red one cover that? Is that closed in the same spot? Yes, so then it's going to continue to infinity. So it goes, the second part goes from 0 to infinity. Oops, bracket. Okay, do the next part. I think you can do increasing, decreasing, and constant. We don't have to worry about brackets or anything because none of those use brackets anyway. So just figure out what is the red piece doing, what is the blue piece doing, what is the green piece doing, and write those intervals. It's not that bad. Just wait till we have to actually graph those things.
When I had a adult job one day, am I gonna look back at this and be like, how helpful? Sorry. You're gonna be working at Payless. You're gonna be like, this is how I measured the trajectory of your big toe.
What is the red doing? Increasing, decreasing, or constant? Decreasing. So what would the decreasing interval be?
Negative infinity to 0.
There you go. Okay. What is the blue part doing? Increasing. What's that interval? With increasing, decreasing, and constant, it's always parenthesis because you can't be increasing at one particular spot. That's where you stop. Okay. And then what about that green piece? What is it doing? Constant. So that range is going to be 2 to infinity. Yeah. Now, last piece. Give me just a second. All right, f of 0. What does y equal when x is 0? 0, because there's a closed point there at 0, correct? This one right here. All right. F of 2. Let me erase my stuff. This is where we have to be careful. So here's 2, correct?
Yeah.
But that is what kind of circle? Open, which means it can't be equal to that, right? And that one is also open. Is there any closed circle where x is 2? No. So what that means is that particular one is undefined. There is no point on my function where x is equal to 2 because it's open circle at both. And then what about negative 2? What would that be? 3. Okay, go to negative 2, go up to where your graph is. That's 3.